Hello, I'm Atom, your friendly guide to the wonders of space. Join me on this exciting journey as we explore the captivating realm of freefall physics. Have you ever heard of the incredible experiment carried out by astronaut David Scott during the Apollo 15 mission on the moon? It was truly a showstopper and still is today. David Scott dropped a hammer and a feather from the same height on the lunar surface, and guess what? They both hit the moon's surface at the very same time. It's mind-boggling, isn't it? But why did a heavy hammer and a light feather fall at the exact same rate? What is the secret behind this astonishing phenomenon? Let us unveil this mystery together. So that brings us to freefall. And what exactly is freefall? You see, freefall refers to the act of falling through a vacuum or no air. And on the moon, there is no air. So the only force that acts on objects in freefall is gravity. Imagine we drop a 1 kilogram cantaloupe and a 5 kilogram bowling ball from the same height at the same time here on Earth. Each 1 kilogram mass is pulled towards the Earth by a gravity force of 10 newtons. So, there is a 10 Newton gravity force pulling the cantaloupe down and a 50 Newton gravity force pulling the bowling ball down. Take a look at these free body diagrams that show the forces acting on the cantaloupe and the bowling ball. Let us calculate the acceleration of each object using Newton's second law. Acceleration equals net force divided by mass. The acceleration of the cantaloupe is 10 newtons divided by 1 kilogram, which equals 10 meter per second, and the acceleration of the bowling ball is 50 newtons divided by 5 kilogram, which is also equal to 10 meter per second. So, all objects, regardless of their mass, accelerate at the same rate and hit the ground at the same time in a vacuum. In other words, if you have a big mass, you will experience a big gravity force or a big net force. And if you have a small mass, you will have a small gravity force or a small net force. The ratio of this force to the mass remains about 10 meter per second in a vacuum on Earth, which is also known as the acceleration due to gravity, denoted as g. Now, let us add a sprinkle of fun. At the end of 5 seconds, what is the speed of an object in freefall that started from rest? Pause here and check your answer. 50 meters per second. Is the velocity in freefall increasing, decreasing, or staying a constant? Pause here and check your answer. Increasing at a rate of 10 meters per second for every second of fall. Is the acceleration in freefall increasing, decreasing, or staying a constant? Pause here and check your answer. It remains constant at 10 meters per second, which means the velocity of the falling object increases at a steady rate. So, there you have it. We have unraveled the magic of freefall physics. Thanks for joining me on this madcap adventure through the mysteries of the universe. If you have got more cosmic questions or want to dive deeper into the science sandbox, don't hesitate to ask. Until next time, stay curious, my fellow cosmic explorers. Thank you.